Dear students, this is part second of this chapter. Here we will discuss how to balance a chemical equation and the two main types of chemical reactions, that are combination reaction and decomposition reaction. Balancing a chemical reaction. In order to get the stoichiometry of a reaction right, we have to balance a chemical reaction. To balance a chemical equation, first draw boxes around each formula. Do not change any inside the boxes while balancing the equation. List the number of atoms of different elements that are present in the unbalanced equation. Start balancing with that compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has maximum number of atoms. Balance the unbalanced atoms and finally check the correctness of the balanced equation. We count atoms of each element on both sides of the equation. To make a chemical equation more informative, the physical states of the reactants and products must be mentioned along with their chemical formula. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations like G, L, AQ and S respectively. The word aqueous AQ is written if the reactant or product is present as a solution in water. For example, twice H2 plus O2 gives twice H2O. Here 4 hydrogens plus 2 oxygen gives 4 hydrogen plus 2 oxygen. Balanced and unbalanced equation. Here we can see in the first reaction H2 plus Cl2 gives HCl. It is unbalanced reaction as the reactants and products are unbalanced, that is hydrogen 2 in the reactant side, while as product side there is only one hydrogen, while as in reactant side there are two chlorines and in product side there is only one chlorine. So this reaction is unbalanced. In the second case we have H2 plus Cl2 gives twice HCl. This reaction is balanced chemical reaction as both hydrogen and chlorine are equal to each other in both reactants and products. Now we will see the various types of chemical reactions, that are combination reaction, decomposition reaction, single displacement and double displacement reaction, and finally the redox reaction. So combination reactions, those reactions that occur when two or more reactants combine to form a single product are known as combination reactions. For example, calcium oxide plus water gives calcium hydroxide. Similarly, carbon plus oxygen gives carbon dioxide. These reactions are combination reactions. They are generally exothermic in nature, that is, they involve evolution of heat during the reaction. For example, we have twice Na plus Cl2 gives twice NaCl. Here there are two sodium atoms and two chlorine atoms. They combine to form two NaCl atoms. General formula is A plus B gives AB, that is element A or compound A gives plus compound B gives compound C, that is AB. Decomposition reaction. That type of reaction in which a single reactant breaks down to give simpler products are known as decomposition reactions. For example, twice water gives twice H2 plus O2. When a decomposition reaction is carried out by heating, it is known as thermal decomposition. Similarly, if the decomposition is carried out by the help of electric current, it is known as electrolytic decomposition. Here are few examples like twice H2O gives decomposes into twice H2 plus O2. That is, general formula of this reaction is AB gives A plus B. Some famous examples are hydrogen peroxide. H2O2 decomposes into H2O plus O2. Similarly, electrolysis of water, that is H2O on the passing electricity gives H2 twice H2 plus O2. Similarly, nitrogen triiodide, that is twice Ni3 on decomposition gives N2 plus 3 times I2. And general formula of this reaction is AB on decomposition gives A plus B.